So, let's bring that closer. Listen quickly. Yep, sound is good. Fantastic. All right, round 2 for today, and we want to work further on our application. And to get started, I have this part in my head that I want to change, because if you take a look, we have this if command and we have this if command once more, and it looks really ugly. So what we can do is we can create, for example, wrong keyboard. So the first idea is to create here like clear end or point. We pass inside a point. Something is weird. Let me restart quickly Android Studio. That looks completely off. So Android Studio. Okay. Yeah, that's better. So we have this clear point function, and we can reuse that, because what I want to pass inside is the home view provider dot endpoint. And here I create this method. Exactly. So, and the thing is, we want, or what we need is the read home view provider. So this guy, so I will pass that also inside. Now we add this required parameter. This is our home view provider. And now we actually just add the whole part here inside of this method. So down here. Okay, so this will be home view provider dot update cell. And instead of having these points, we just use the endpoint, or better, just the point. Good. And with that, we can also remove this. We get a nice little one-liner, and we can remove that here. On the other hand, I'm not 100% sure if this makes it really easier, but let us think about it. So what happens if we add this endpoint null check also inside here? So if we say point unequal to null, then we do this. Now we can remove that part too. So we clear the point and we set the endpoint if the active tool is the endpoint. And with the active or start point, we do exactly the same thing. So what we can do is just call clear point and give the point inside, which is the home view dot start point and the home view provider. So, not this home view provider, that's important because we want to read against home view provider, else it complains about read and watch error. So chat is also open so that I see you. Okay. How could we distinguish between these two in an easier way? So I could also say, because we want to clear the point in any case, right? So both of them still look a bit too easy. Wow, what is the music? So let's reduce the sound. So. Good. So this still looks very intriguing. Like we could also even be more smaller cased in this case. So at the moment, I would still even say that we don't need this method. Actually, it doesn't add so much value to it. Could we also check the cell state here inside so that we don't say only clear point, but more, I don't know, set endpoint, but we don't really set the endpoint, right? And I don't want to do too much things that is hidden somewhere. Could we not give all that in this update cell? Hi Deepak, welcome back. So, so where have we been the last time? So if we start up our app, where do we have, or will we be? Remove that. And how was your break in the afternoon? What did you do? Okay, so now nearly everything works the way like we want to, right? So we can just update whatever we need and get our values here. Cool, but now our breadth first search and the searches will not work correctly. So we have that on tab method. And then we update the cells. I think that works already pretty well, right? So yeah. So don't waste too much time in it. Let's see if we find the next part. So all of that is currently UI improvement. So I will update the GitHub with that. So on the other hand, on master should always be a running stable version, which we don't have here in that moment. So let's see what we still need for the search. So we had some stuff here. The first thing is I wanted to remove this part and give that into the parent. So how or what you can expect from that. So because this is a hard dependency, we cannot really test this on pressed at the moment. So for that, we could use getIt for that. That would be one option. Another option is that we just use basic injection for that. So how does that work? We would create this search algo implementation. What is the name? Search controller. Good. And then in the home view, we have to make that final, of course. And I think then we can even create the constructor for it. Don't pass the key inside. Good. Why is it red? Oh, because of private, right? Yeah. So let's don't do it private in that case. Or we can make it public. I think shouldn't be a problem here. So, and with that, we receive that search controller from outside. So whenever we initialize home view, we have to pass it inside. So that means also that this one is required, else our app wouldn't work. Okay, and in the bottom, we now would use, where is that to do with that? Here. We would not use the search implementation. We would just use, we could even get rid of it, I guess. Why do we use it anyway? Here, the search controller. So it's automatically changed and that should work already. So, but important for us is that now the application will break at the moment, because whenever we initialize, we have to pass that in. And this is a search controller implementation. Fair enough. So now the home view is a bit more solid and we got rid of some stuff. Okay, next step. What do we have here? Result. We do a lot of logic here inside, and I really don't like that. So actually what I want to see is something like await, search controller, or not even that. Actually, I would like to do that via the provider. We have already our home view provider up here. And the idea would be that we just call something like, let's go, do it. So start search. Create method, that's it. So now inside of that, we can call these methods if we want. That is reset results. Results. And the other one is start timer. So. And then I said get rid of this switch method here. Well, let's keep it for now, but bring it inside of the start search. And then stop timer. And now I see right now that we don't depend actually on the search controller here inside. So the home view does not even need to know this. And the stop timer can be also here inside. Oops. Not like that. Command B. And bring it on the bottom of this. And there we have already stop timer. All right. So with that, we cleaned that up a little. And now what I saw is that this home view does not even need the search controller. So we can get rid of it. We don't need that. Don't need that. And inside of our main, we even don't need that. So. Okay, still things are breaking. That's true, because we don't have here anything like that. We could now say that we depend here inside of it, and then we would pass it from the home view here inside. But there is a more elegant way. If we really need that down here, and I see right now that we have a bit, oops, that was wrong. You have to go on top of these whole getters and also this method. Okay, so let's see. In my case, what I would like to do is whenever we initialize this home view provider, we will get this search controller inside. No, that is the search controller. And I think what we can do is make this way. Import. So we have that, and somewhere we initialize, probably here, where we create the change notifier provider. And here we can now initialize our search implementation. Okay, so with that we have this. Why is that? Avoid defining parameters in constructors. This makes sense. So this dot search controller. And now we can directly access the underscore search controller. Nope. We want to make this await. So this here is async, which then returns a future of void, which I guess makes sense because we wait anyway for it, right? No. No, we don't have to await actually here. Okay, and then this all happens, and now it needs the home view provider, which is not really true because we are the home view provider. But it needs the methods from here. So can we pass in this? Indeed we can. So maybe this is our solution for it. Isn't an instance of a field of this class? Yeah, because this is private, so this works. So, and now currently we make this start search inside of the search controller. And because it's anyway a start search, we have deep first search. Exactly, we do kind of that already. So even here, I would like to not have this switch case, but rather instead of passing in true and false here, I would like to pass in something else, a bit more sophisticated solution. So we have this deep first search here, and that would be gone and replaced by the values that we can have for the search that we currently have on the home view. So we have up here the search algos that we can use. So if we change that, or active algo rhythm, exactly. So here's something red. What did I change now? This is the implementation. So yeah, you are broken, of course. So all of these are not necessary anymore. Because if I do that, we can get rid of this. Active algorithm is the one that we get. And this is the only thing that we need. So search, or can we even, I think we have it here. Active tool, I don't know, do we have also the algorithm? Start point, end point, selected search algo. Yeah, we have that. There's a comma missing. And something is oddly wrong. That's done. So here I said active algo is the selected search algo. But stop timer, why is it complaining here? No usage found. No, wait, you are wrong. Okay, good. Next step. Now we call that. We have here the start search, which has changed because we don't have this anymore. We have now search algo. Yeah. Good, and now the implementation breaks, of course, because we make currently the check against that. So, and dependent on if it is search algo dot I think DFS or search algo BFS. No, wait. I think we now need maybe the switch here inside to decide what we need. So for example, we would do something like that. The frontier, if active search algo is equal to search algo DFS, then we would get the return, the final frontier would be the stack frontier, right? Else Q. This can be gone and the rest should work. So now we have to define that on top, of course. And then it cannot be final anymore. And here we need also an if statement because they could change, of course. So we have this active algo again equals to search algo dot BFS. So and these are the only options that are included at the moment. Seems that we have a problem here still. Function list still state. And this is also not anymore true. Good. So. Okay. Next step done. Do some smarts. We go here inside and run this one. I think these three would not exist anymore. But yeah. And this would maybe also reduce the amount of search algorithms that we need. So like we currently have for each an own method, and I think we don't actually need that anymore. So, okay, that was quite a refactoring, but that's okay, I guess. So do we have cells here anymore? Do we use them anywhere? Yes. So we do it here, reset results. What did we do for that? So we checked all the cells, and if they are a solution or if they have been visited, then we change that to path again. So if the first two are correct, the only thing is that for loop that we have to change, because we have to work with our grid, right? So well, the easiest way, but most likely not performant way, would be to create two for loops, like a column in grid. And inside of here we would have the row in rows, in grid, no, in column, up, like that. And wait, this would be not row, this would be cell in that case. Equals to cell state dot path. Because it's a so we could say if cell is solution, so we can have that. And then we would set that finished. Yeah, as I said, it's not really performant because it runs through the whole grid all the time, so it will take some time to run. But I think that should do the trick actually. So we can get rid of this cells part. So, and where's the other cells used? Command B, down here. Okay, can be done too. Cells.clear. Okay, what did we have on clear? It's to remove and clean up the whole cells element. Or you can remove that. Cells.clear, and this was to recreate everything, so recreate grid. Search gets the cells, which is not true anymore because what it receives is a list of cell state, which then is our grid. Okay, so we updated everything to grid. Now only the implementation is missing. Last steps, you could say. So let's begin here. So int start and end. I think we don't need these integers anymore. Okay, let's fix first this down here. So we have here list. Sorry, my this is a grid. whenever I make a tag, this is my push to talk for Discord, so it will always make this noise at the moment. I will have to change that sooner or later. Okay, so and then I called this get maze information. So start and end point we can get directly from the provider, so we don't actually need that in this case anymore. We can just pass in this provider, and we currently give this grid inside, so let's add also the provider here. Add required, yep. And these two would then go to provider dot start point, and this would be provider dot endpoint. Good. For these two, they will have to change because they are now tuple 2 from int, and a tuple 2 from int, which is the endpoint. So here it complains because we don't give inside as grid, we give at the moment cells. Keep that and change that to a list. Grid. So it needs to a start or end position, that's correct. So what this means is actually that start and end cannot be null, right? And this was -1. So it was searching for these points, right? I think we have to validate that still, so that's true. So in my opinion, that would be start equals to null or end equals to null. And what I think is we can directly access the home provider for them, or do we need them anywhere else? No. So what we can do is check the end here directly. Check the start directly here. Get rid of everything else. Okay. Cells as map for each cell state. So now here we calculate all the walls and so on together, right? So I guess that would be also again a for each and a for each here, if we want to do that. So for column in grid, then we had a for final cell in column. Okay, and then we would have our switch with the with the cell, which then contains exactly the same logic, I guess. So, and all walls add index. So at the moment we pass in the position where this is. Interesting. So what we need is for this for loop an index for each element, and I think we will not get that from here if I do the for loop like this. Because now all walls will be, at the moment it is a list of numbers, but actually it will be a list of tuple 2 with int. Same thing for all paths. Like so. Okay, what is your complaint? Exactly, so because the node has now changed, the state of the node is also not anymore a basic int, it will be a tuple from int. Cells add node state. What happens here? It tries to add an integer, but what happens, or what this is also a tuple 2 from int. Okay. And these cells are now, yeah, same thing. tuple2 from int int. Can't be returned from a method. So yeah. Okay, so the problem is that up here the method says that we return something different here. And this will be in the implementation too. So good. Explored at, okay, explored has the same problem probably. So, and this neighbors method gets now a list of cell states. Probably it will get the grid here in that case, right? Yeah. So it will get the list and list of cell state. And this int is not anymore an int, it's a tuple to int int. So. So state is the current position where we are, right? So up would be, all of that has to be a tuple. So, and the idea is that we create a tuple too. And if we say we want to go up, it would be from the tuple where we are at the moment. Let me think. So we go, the column stays the same, we go up, that means the row goes -1, right? So I would say we have here the state.item1, item2 -1. And then down would be exactly the same, but the opposite. So rather than these all, we have here +1. Then we have left. And the good thing about all of these changes is now that this will be super easy to do, right? So because that will be -1, that will be exact the same. And last but not least, +1. And then we had this remove where. So the values, now we have to identify which parts are not possible, right? So if we are on the complete left, we cannot go one lower. So actually what we can check is the state itself and just say if it is 0, we cannot go to the left. And then the value should be in up, down, left, right. Null, I guess. So let me think quickly. Result remove where value, we don't have access to the value anymore. But this is a good point. So at the moment we have the cells here, so this could be grid, right? And the value can still check for the walls, and that would be remove where grid value, no, but a grid key value. Why is that? Sure. Yeah, no. Yeah. Value.item1 and grid value.item2 is equal to wall. That makes sense. Then also important is that where where value.item1 is equal to -1, right? Or value.item2 It's equal to -1. Or is a wall. And then we return the result. Yeah. But this is not anymore a map of string to int. It is a map to tuple to int. And this will be the grid. Explores contains state. Okay, you still have the problem that you think you are a basic integer, which you are not. Rest should stick the same, close to it. Node state equals, I'm not sure if we can we compare tuples like that? That I have to Google. Tuple dart or pub.dev tuple. Can we compare them that easily with item C object? With item 1 is C and item 2 is 10. Okay. Fixed tuple 7s equals operator. So from that looking, I would say it is included. Hi Minu, welcome back. Ooh. Yeah. I'm not sure about that. Okay, I will have to make there a quick test later. So let's make here check if, or to do, check if equal works in tuples. Or we can do that right away, I guess. So if we check here, we have this tuple, and important is that the equals operator is correct and works. So yeah. Okay, so it's checking already both items, as you can see, the check operator. So equals is overwritten. So I would suggest that this works actually here. Good. Next step, we have all walls at index, which makes no sense because this will want to have a tuple, I guess. And all walls needs an integer to integer, and this cell returns a state, unfortunately. So with this form in, I don't get an index here, right? Doesn't look like. Dart for in index. As map for each. Okay, no built-in iteration. Okay, unlucky. So that is not quite correct then. So that would mean we have to write the for each here complete. For I is equals 0. I is smaller than grid.length. I plus. And here we would copy the whole thing and call that J. J then grid I.length. And down here we can remove that. And the cell would be grid I J. Good. And here we add a tuple. And a tuple from part. I don't know if I have to recreate it. Yeah. So that would be I and that would be J. And the same thing for the second index. I is in that case the column and J is the row. Why is that complaining? Make final. Okay, we don't. Yeah. Fair enough. Oh no, not fair enough. Careful what I'm doing here. This is of course a row, but we want to get that's even true. And here we don't want to increase the column, we want to increase the row. Good. And if we don't do anything here, we can also run that through. What is that? Reinstantiate a zip. Provider update cell. Okay, let's see what happens if we instantiate. We get this and update cell. So we go into the grid. So why do you complain? You get a node state and visited. No, actually that's correct. The problem is only that we want to get item 1 and node.state item 2. And let's face it, why do I need to do that all the time everywhere? Col and row, because of, but I could also pass in a tuple. I think that's cleaner. So I would, instead of give the column and index, I would just give the location, tuple to int, like a point. And then it should do it here inside. And this is not the point, this is the cell. Cell item 1 and cell item 2. Good. Then this here would a little bit change because we need now to create a tuple 2. Col and row. And these two things would not even have to create anymore, just point. And here we would stick with the node state. Good. So home view is red, but everything else is green. That's good. So it complains that there are no cells anymore and delayed is not necessary anymore. That doesn't sound right. We take the value directly. Yeah, that makes sense. Okay. Good. Okay, that could work now. Good that we didn't have wrote any tests so that we probably don't know if something don't work, you know. So that's the implementation here. You know what? We don't actually need this implementation anymore. Cancel. I would like to remove that. Inside of here, get rid of that. And don't call that implementation anymore. And I think also here we have a problem now. Yeah. Better, we still need that, but we need now the real implementation of it. Not this guy anymore. So, and you will also take the implementation in a second. So we remove you. And we rename this to search controller. And now use that wherever we need it. Hub. And search controller. Okay, hot restart. Oh, we get an error. Dynamic cannot be assigned by type search controller. Search controller is dynamic. I think you are confused. Okay, that was odd. Good that it works now. So, okay, let's create some walls. Still working, right? Let's see, we have created this one and the endpoint, delay, start. Okay, so it don't do anything anymore. Okay, this was expected. So it immediately stops somewhere. So that is interesting. Home view provider. Did we forgot to await? No, this waits. Search controller, but maybe we don't wait here. Nope. Okay, so there is more broken than this. unfortunately. So this is green. The method doesn't override an inherited method. Yeah, that's true. Can go away. So here the start search. We have the explore tiles, which is a number, or better an integer. Then we have the starting node. We pass inside the first element. This should be our start. Exactly. So that works. We got that. Then we create our frontier, which is a stack frontier or queue frontier, depending on the algorithm that we take. And then we pass inside the start node. And we have here a set of tuples, which is empty. So while true, the frontier isn't frontier empty through exception. So here this could be the first place where it breaks. Do we get any error message? Not really, right? Like start and end and go. No, nothing happens. So what happens if I miss anything? Also nothing. And we just go to 1. So something seems odd. So we go into this part, right? We update our result steps. If node state equals end. Node states equals end. Okay, so I guess what we need is a debugger. Yep. And I need to be a bit closer. Okay, so back here we create our start point and our end point, and I know we are already here. So start. Okay, here we go. So the node start state is null. That is really bad. Why is node null? Here it is something, but we get null, null, null. Frontier remove of the node. That cannot be. Frontier remove last. List remove last. But we added something, right? Maybe we have a problem here. So we add this node. It's null. And the end is true. What did I see? What? Slowly. So we have the node, which is a node, and the state is null, the action is null, and the parent is null. And the frontier is a stack frontier, which has a size of 0, and the start node is also null, null, null. Huh, something is odd. Where is the start node? This is that one. This state is a tuple of int int. The grid. Start node. The grid is size 8, yeah, with 8 times 8, that makes sense. Delayed is false, that's okay. This returns void. Why is start null? We need start. Yeah, sure. Because we get that from somewhere else. This is of course provider.start. Here we go. That makes more sense. So of course we don't have. So now I understand why we need these two. But what I don't understand is why it is not removable. I think we can even remove it, right? Because you are now the provider.endpoint. Yep. I think that makes more sense. Restart everything. Okay, so here we are again. We have our start point, we have our end point. We click on start end. And do we have now something? Node state, aha, a tuple with 1 and 2. Makes this sense. Our start point is first, you can see if I put it on the monitor, but you have 1, which is the first, the 0, 1, and 0, 1, 2. So it is perfect. Yep, that fits. And let's go further. Let's just let it run, I guess. And we crash somewhere, which is fine. Range error. Not inclusive range 0 to 8. Okay. So somewhere we throw an error. Yeah, break a little bit. Okay, so it tries to access 8 because I was a bad neighbor. I did not check something. So you see, I checked that it can be larger than smaller than -1. This is not possible. But on the other hand, the value the item 1 is not allowed to be larger than the provider dot rows, I guess, or columns. Wait, I first have to get this field. So we are here. So where do we get the result? I think we get here the provider access. So what I can do is just add provider dot columns. Add required. Good. So these columns is more the column amount. So what we have to say is that value item 1 is not allowed larger. Remove where it is larger than the column amount. And important value item 2, the same thing for the row amount. We are not allowed to go on the right here, right? Would that be even possible at the moment? Well, the column amount makes sense. The row amount would be down here. Yeah, that makes sense. So int get the row amount. And here we would have the provider.rows. We have here 8 and 8. We cannot be larger. I think we cannot even be equal to it. But okay, we will see. That's a good thing. We can test a little bit around or play a bit around. I think this will be more like this, to be honest. So let's see. We have our start point. We have our end point. And we say start search and we crash still. 0 to 7, but we got 8. Probably it did not get... column amount -1, I guess. Okay, there is no solution. Okay, that... I think I did it now twice, right? So... yeah, now it found the solution. Okay. So we have now 8 to 8. We have an error, invalid arguments, needs an end and start position. That's good. Still have to create an error message for that. And we find that. So now we can create crazy amount of parts here. And it works already. Not too bad. I'm a bit surprised, I have to admit. So delayed. Yeah. Oh, the search duration is not updating. Huh. Yay, it really searched everything. Okay. So this is 8 times 8, but what happens if I make 12 by 12 or something? So now still working. This works, and put a wall in between. Let's make something really big, because at the moment I still can do it. Ooh, that's too much. I think this is not really... kind of this. So let's create that. We have here one, we have here one. In 5 microseconds is that, so that is milliseconds in 5,000. So in 5 milliseconds we will find this in this huge grid. Nice. Okay, so happy days, right? We can push that. So this is all done. Updated to a more dynamic solution. I just hope that we didn't forget some edge cases, but we will see. So reinitiate, I think we can get rid of that. What is this? Why do we have that twice? Ah, this is for the solution. We forgot about that, that's true. I think we can also remove that because it should work now already. So if we have the starting position and the end position. Yeah, I think both of that is absolutely correct. That's why we did that. And also the solution should be in blue. And now I cannot set anymore an endpoint. Yep. What we start quickly. So start point, end point. Ah, perfect. Start. Good. So now we get again the blue line. And the endpoint is red again, so we can search right away once more. Ah, the clear is not working yet, right? So if I click once more, it should clear the solution. I thought we have implemented that already. So let's see, view, home view. So whenever we do that, before we do it, or better inside of this search, reset results. So this is not working correctly, it seems. So the cell state, so probably we don't update correctly. So that means when it is solution or visited, we make it to a path. But I guess we have to do the same problem like before, right? We have to write the full thing. So var e, make a big maze. I will do in a second. I just want to get this done here. Length 50 times 50. All right. And I think I found already one flaw in our application that we have to recreate in the future. J is smaller than, this is grid I, J++, we get that. And now we, if the grid on position I, and this gets of course the length, ij, then we set that to the solution, the same thing for the cell on the other side, and the same thing for here. And what we can do is creating for that just a point. Okay. Like give it the cell equals this. And I think that should do the trick. That could be final even. Good. So let's see if I press start again. Yeah, so you can see now it's getting empty. The problem was that we didn't access actually the list, but what we did is actually access an element on that. So we needed to access the list and really override that with a path. So you can see beforehand, wait, I can get back the old solution quickly just to show you what's the difference. So back. So up. So this was the solution beforehand, right? Before I started to, maybe not completely. So like that. So this was the solution beforehand. So if I press now start search, this happens. Line 79. This one. Change it to cell there. No. Exactly. Yeah, that could work. I'm not sure if this works because I think we have to modify the map or the list itself. If we say now cell and we pass that, and that will not work, I guess. Yeah, at the moment it's a final, but what if we change that? We change this value here inside. We don't change the reference to it. Yeah, so you see it's again blue everywhere. So we have actually to do it like that. And if I press now again, you see it's completely emptied. And I think that is important for us. Oops. 1 second. Cool. All right, so change that to a dynamic way. I think we did that. Can be pretty happy with that. And I made a mistake here. Up. So, yep, that's exactly the next step is that we say breadth first search and I press search. Yeah. Up, down, left, right. That looks all good. If it hits the walls, it doesn't add them up. That's also good. No crashes anymore. And with that, we have managed it to really implement. So the next step is we can do, always forget to update the keyboard. So now let's first push that up because now we have a dynamic added the made the maze dynamic in rows and columns and push. So fair enough. Next step, I think I created this list of to-dos here inside. And actually what I thought about it, or when I thought about it, we have now a GitHub repository for that, right? So if we check for the GitHub, oh yeah, 50-50, we can do that. Sorry, didn't want to ignore you. So 50 and 50. Let's have a starting position over here and a starting position over here and maybe make it a bit bigger so we can see also something. Or we can make it even full screen. Or Notion, yeah, good question. So Notion, or I wanted to make it directly in the GitHub repository and the GitHub project. So kind of this, and I think this validation message could go away. I think that heavily depends on the machine that you have. So we can add some walls. Don't know, kind of this. Putting stuff inside. So. I think I have to improve the maze a little bit. This whole clickering is really annoying. So it would be better like in Paint or something that you can draw a line on it. I don't know how we can do that. Oh, I think we shouldn't delay that. That could take a long time. Way better. Okay, so we need 8 seconds for it. And now something weird happens. So if I'm searching once more, we have to kick the process because in front of it. Blocking the path. Yep, we'll do that. Just quickly wait until the old search algorithm is done. Or better, let's restart here quickly. Up. Good. So that was 50 by 50, right? And then let's block the path. So we get a wall. No, I don't click 50 times, sorry. Start position is here, end position is over there, and go. Yeah, perfect. So it couldn't find a path. Spamming caps? Oh, sorry, Minu. I don't know where this comes from now. Big bounty bug? Which one? Where is the big bounty bug? I think there are a lot. But I think at least it is dynamic at the moment, so we can make it dynamic if we want to. It could be a bit more beautiful in general. That is something that I would say. So at the moment with that amount of pixels that it's going down here and so on, that's a bit crappy. I think what Simon said would be a good idea that we make it by logical pixels. So if you have so many spaces, then automatically you get so many rows and columns, and then you can draw inside of it. Ah, yeah, the problem didn't stop. So for that, I would create a to-do again. And as I said, I would do that on the GitHub itself. So let's search for it. We have the maze. Issues, create a new issue. So search goes further after another search is created. Yeah. So what we can say, I can create a screenshot for that to. I think the app is stuck at the moment. So start, click that, and we delay that, start the search, we click just once more, click once more. Do you think it's a bug? I mean, come on, it looks amazing. So, all right, so that means we need some kind of callback, and as soon as we click again, we want to kill the process that is currently running. But yeah, let's first create the issue. So, the wished behavior would be cancel the first search, start the new search. Or oh yeah, that's also good. That would be even easier instead of canceling and stuff. I think if we just, yeah, disable the button. On the other hand, it makes it a bit slow, right? Because if I disable it and on a very big one, I have to wait long till it's working. Search, cool. and submit. You know what? I will take that button right away because it is amazing and easy to implement. So I assign it to myself and let's create a pull request for that. Ah, okay, so this is the idea. Okay, so the idea is more to create another button, show another button that allows to cancel the current search. Okay. How would we do that? So actually the only thing that is running is that search the while true, right? So if we change this while true to something like while allowed or something like that. That was my first idea, Minu. Now I'm confused. There is no kind of if loops, but thank you. So yes, we have the provider here anyway, right? So we could check something or get something here. And what we need is, let me think. So inside of here, we start the search at the moment. We get all of that. So slowly. First, let's think what we have to do. So this search, start search would be changing, right? We will have here multiple ways. Could create two buttons, which would probably be not a good idea. But what we have is like two states, right? For this button, we would have active and cancel, or start search and end search, more or less. Should everyone be... Yeah, I know we don't need two buttons, but we could have that, because if we don't use two buttons, we will have to write all the different parts. So, but slowly, let me think quickly. And then, so we have that part, and we could say something like, okay, we get anyway the home view provider, right? View provider, and let's say we have, we need a state, right? So something that keeps up with that. So, active, or is search active. Then we show not this, the opposite. We would have a const with the text, cancel actives, or cancel search. Else we would show the search start. Here we create the local variable, which is at the beginning always false. Oh no, not like that. Also an idea. So like that, and give that to false. No, I don't do that, because what yeah, that's getting so many conditions now. Yeah, okay, let's do it like that if you want to. So start search, and here we remove that, get this place. Evaluation of this content expression throws an exception, because this cannot be a const, of course. So, and then what we have to do is also make that colorful different. Yeah, no, it will not stick with a single line, I guess, but let's start with that. So if I press now start, okay, where comes that from now? Okay, so when I have a start and an end point, and I press this button and I press start search, okay, we don't have this inside of our reset function. To the GitHub. New issue. Reset button does not reset the start and end point. Good. What the hell? It's magic. Cool. So you are Boolean, exactly. You are false. Recreate grid. Would it be part of that? Update row? No, it would be the reset button that we have somewhere. So reset result would also say that no, this is something else. Is search active? Whenever we start with the search, where is it? Start search. We also set this guy to true. And whenever we are done, we set it to false. Good. And now in the home view, we have now to say then this, else we say stop. Yeah, so cancel search. Do we? I'm not sure if we have to update the UI for that, because no, I think we don't have to update the UI for that. So this can be a basic override. So is search active will be false. We don't have that function yet. So what's that? We don't need an await for that. Yeah, so it's good. Okay, so in the next part will be inside of our search controller, I guess. And in the search controller, we want now the while true replaced by that provider. Is search active? So only if it is search active, we can run here, which is nearly always true, besides of if I cancel. So we have a start, we have an end. Wait a second. Of course not. Yeah, wait. Not here in the home view. We cannot use that. We have to update it somewhere. So if we set that to true or false, we have to toggle that. That means we have here inside a toggle function. Search active. Toggle search active. Wait, no. So, and is search active is equal to is search active. And the important part is that we have to notify the listeners. And this is the opposite. Ah. Yep. So let's see if that worked. No, sadly not. Okay, we toggle that, we notify our listeners, and then I thought actually probably I have read the wrong way around this is search active. If it is active, we show that, yeah, it's exactly the opposite around, right? and I think we cannot just make this assumption, because if we change that, we have to toggle it, right? So we have to use the context.read, or better, we use the same thing like below. Up, and we toggle the search active. That makes no sense. And up, so up as an update search active. And not a toggle anymore, so whatever we receive here is search active. For you, that means you want to update it with it is active, so this will be true. And down here we will use it where we set it as inactive again. Good. Okay, that was too fast, delayed. Yeah, so now we have to cancel search. Hoo-ha. Okay, so somewhere we break the whole thing. Boolean expression must not be null. The home view widget framework. Ah. This can be null. How can that be null? It's false in the beginning. True, false. Did we use that somewhere with null? Ah, yeah, here. Is search active? If it is, then this is cancelled and we have false. So try it again. This one, and stop. Okay, that was quick. Let's try it again with delayed. And cancel. Okay. I guess that's it what we need, right? So the last thing that we want is styling. Like text, button styling? No. What do you have for style? Button style. This is shape, alignment, background color. And what I want to say is if the home view provider dot is search active. So if the search is active, I want that the color is red. Const of course, and this is red means RGB, right? So we have FF0000. Else we have the color const, sorry, XFF, just the primary color, theme data dot off, button color primary, blue, green, computed. Up. Primary color. Here we go. Okay, I will show you in a second. Sorry for that. So where's the error here? Material state property color. That's a bit unlucky. Okay. What is that now? Material state color. What do we get here? Int default value, super default, creates a material state color, resolve with. Is that abstract? Yeah, so how do we use that now? Color, resolve, material states. Defines a color that is also a... Pressed, focused, hovered. You can either create a subclass and implement the abstract resolve, use and pass in a callback that will be used to resolve the color in the given states. Dot resolve with. And it wants now to get a callback. Which callback? We get a color here or? Resolve with the material property resolver color. Material property is a function with a set of material states. Okay, so these are the states. And we have to return a color. Good, so resolve with, that's the trick. Okay, get this in place, and now we can have this, we could have now a lot of if statements, I guess, against all the states that are there. So is empty, is not there, contains all. I would have guessed that there are more states, so we have material states. And this could be hovered, focused, pressed, dragged, selected, disabled, and error. Fantastic. So, but this is our general state here at the moment. You have sent the style encoding, okay. Yeah, no, why? No, the thing is, I want to show the button in two different colors, right? If now it's red, if I click it, it should be blue. So that means to create it, I have to create the whole thing with this home provider active search. That's why I was saying that it would make sense to create two buttons, because the one could be blue, the other one could be red. But now we decided for this way to go, and now we have to provide the whole thing, right? So gives another button style, or don't even, we can just return the different color, I think. So here in this case, what we could do is home view provider dot is search active, else const color 0x ff. Now we want to make it more bluish, or primary colors actually. So theme data of context dot primary. Theme data dot off context dot. Why can I? It's interesting that I don't have that in place now. Okay. Yeah, so finally, let's do it this way. So start, stop, start, stop. Okay. Good, we have our start location, our end position. Good, so one or two problems that I see whenever we change now this search. So for example, I have this and this, and I swap in the between this, then you see the code is still running further because it's just resetting, but it doesn't cancel it. So we have also to keep track of that. That would be in the search controller, and here we have the, no, that will be in the home view. And here we have our checklist tile, drop down button on change somewhere. Yes, here. So here we need to say the same thing more or less and give it the update, no, search, start search, update search, and to false. Exactly, Mino, well done. Good. And so with that, we have also this place done. Get still some errors here. This function has a return type off, but isn't what? But doesn't end with a return statement. Okay, so it could be null. Is that true? Ah, okay, because sort pub dependencies. By what? Okay, but that should do the trick now. Did we miss anything? We have this. What happens if I clear everything? So I start again, I clear. That's just searching further. Okay, so we also have to skip that. So in the home view provider, we have to reset all, right? Reset results. No, reset everything, but I need reset all. There it was. Good. And here we have also to update search active to false. What do you mean with reset and stop the process? Good. So then I can create a pull request. Okay, let's see. Reset results, update results. Creator, this is done. Reset all was the method, and you say before we regenerate we say false. Yeah, I think that makes no difference. That should be fast enough. But yeah, you're right actually. But then with that the search is done already. Good. So good. So let's get the next part. As I said, I want to commit quickly. So we have made it possible to removed, no, killed active search. Yeah. So push, and I pushed it to master. Ah, that was stupid. Oh well. Good. So now I will have to get the this one. Every millisecond counts. Yeah, that's true, but you know, if you have any way to delay active, and if you don't, then you probably would not even notice it. But you are right, of course. Every millisecond count. Good. Then what I can also add here in that GitHub repository as an issue is I want to integrate the GFS. Integrate GFS. Or let's write it out like GBFS, right? So this was greedy best first search. And new issue, integrate a star search. In projects, I think it's too much, or just to create it. What do you think? But you're right. Yeah, that's true. So search algorithms. Then we have like, can we use a preset to do move issues when newly added, move pull requests when. I don't want to automate now anything. It's too much stuff to do. I just want to have my issues. Sorry. To keep it easy, we want to make it simple. We want to get stuff done at the end. If I always do something else besides of the stuff that I want to do, I think then we are never get finished with that stuff. But it's a very good idea. So if I would do that as a main project and it would get even larger than, I don't know, like a little bit of play around, then we can do that. But for now, I think it's fine to just create some issues. All right, so that means with that we have that solved. So, and reset button does not reset the start endpoint. Okay. So where have we that problem? If we press the reset button, then that is in the home view provider, in the here reset all, and here we have to reset the endpoint, right? So endpoint. Actively setting something on null looks somehow weird, but I think that makes sense. And this would be start point. Good. I think that should be already the trick, right? So we have a start point, we have an end point. Press reset and start. What's now happened? Okay, we crashed. Yeah. We don't show this at when we don't have an end start and end date. We currently doesn't show an error message. So probably we need an alert for that, or maybe some kind of information here. And also we have to cancel the search. So that means where could we catch that thing? So I think here we throw, and we throw up here, home view provider. So we could even try catch on that part here. So, okay, we also need that. So create an issue for that. Good. So, but did that help now to our problem? If we have a start and end, and I click on that and start search, yeah, it crashes, and the cancel search is not working anymore. You know what? I think I will show kind of information. Okay, this is something else. But what's interesting is if I reset and I don't have a start and end position, and I crash, on that error, then the cancel search sticks there. So what we need is we have to change this to a real if else, I guess. So if this guy, then this guy, else. Same problem, Minu, I'm pretty sure. but we can try it. So if I have start and start, we crash. Same thing. Where are we? Here. So if we press that button, actually we have now all the information. What we can do is directly make here an if statement and fail. If home view provider dot start point equals to null and home view provider dot endpoint equal to null, then we wouldn't even start. Right? Okay, I didn't have hot restarted, but I think that makes sense, right? So I define, for example, a start point. I click on start. Of course, not end or. Yeah, so now nothing happens if both are not deployed. Fantastic. Okay. So we can handle that before we even go inside. And what does that mean is we would not handle it here. We would actually handle it here at the start search. So right away at the beginning, kind of this home view provider that is itself. Yeah, it's way better. So now this stays clean and the other thing is a bit more complicated. Good. And I think then we can show some kind of information, showing an error, I don't know, some kind of that. And yeah. Good. So this would be the problem solving for reset button does not show a start and end point. Up. So does not reset, yeah. That commit, this to do we commit, push that inside. Good. So. Oh, that's better. That's a very good idea, Minu. That is a very good idea. That is a very mature solution, I guess. So with that, we have to provide them. That's very cool. I think I like the idea. So that should be also pretty easy because we have already the button here. So that would be this. Don't we have it disabled here? But elevated button. Ah, we have to provide null here inside, right? So home view provider dot endpoint and or view provider dot start point equals to null. Null question mark. Then this is just null, else that. So disabled, can't click it. set a start button, an end button, and we can click it. The only downside is now that the user don't understand what he makes wrong, right? So we have to inform somehow what he needs to do in order to understand where he can find the elements. Ah, you can't see, sorry for that. Bring it up here. So, okay, so hot restart. You can see it's disabled. And if we now select a start and an end, it's enabled. Sorry, I was just a little bit playing around. Good point. We can do this actually. So, oh, that works really good. Really happy with that. So, in order to make that a little bit cleaner, because at the moment we use a lot of these checks. So here I want to pass down a Boolean get check for end and start point. And this returns us endpoint, null, and start point. Okay, null. And not and, it is an or max. Learn that, it's or max. Okay, and with that in mind, we can go now to all the places where we used all of that. If this is null, then first of all, we have to turn that around. Can I? No, I can't do that here. Okay, we will do that in a sec, but this, then we turn that around. And then we return null. And this is the home view provider dot check. Okay, so still working, but now with that in mind, we can now use the tooltip, and this is a decoration, I guess, right? Again, we have this style tooltip. How do I get a tooltip on a button? Yeah, good. So the tooltip is with the message home view provider model check for, then we have start or else add a missing start or end point. Not really the best user experience, I guess, for how do you call it? For mobile, because I think on mobile it's a bit tricky to get this hover thingies, but for that it looks quite good, and we have everything that we need. Okay, so let's see how we can go further. Next steps. So we have finally the start and end position. We can create the vaults. We have the breadth first search, for example. Let's go. We can make that delayed. This is a bit wrong here, I guess. So we have to make a little bit more than this. So, we could create a method for that. Get tooltip. So, and what we need is actually this home view provider, and we have to check a little bit more. So the message that we want to return is a string message, and we want to return this message. and here we say message is equal to that. But I would like to write a little bit join return now slowly. So if the home view provider dot check for end and start date, then we want to return add a missing start and or end point. Home view exactly the opposite. So here we want to return start. Else we would like to return this here. Only one thing is missing, and that is if the home view provider dot is search active, then we would like to return and we don't want to return, we say message equal, also here message is equal and here we would say we don't need the message, we can directly return. So get away with that. Good, we don't need this stuff anymore. So so we have the if the search is active, then we cancel the current or the search, or just cancel. Good enough. Yeah, good. I think even if we don't provide anything, it would be better than this. So if we would just say this is an empty string. Good. Yeah, for a big maze, it's currently not working. That's true. Up. So why do you? So finally back in the stream. Okay, we have all of these things inside. We get all these parts. I think that's good. And with that, we can push that again to master. Added a tooltip. Disabled button on missing start and end point. So you would also remove start. Yeah, you're right. It's already there. We don't have to read that. So actually we would just revert that and remove all of that and say something like if this is the case, else, or in any other case, we default return empty string. Ooh. Not quite what I expected. Okay, so maybe we have to return null in that case. Okay, message cannot be null. So empty string. Bogus. Why? What is he trying to do? Yeah, maybe better better write start and cancel. You're right, but really pretty it is not, right? So there needs to be a better solution for that, I guess. Well. Okay, anyway, and push. So guess what? So we can add this. Good. So then let's try to integrate greedy best first search. And the good thing is with our new created maze with that I and Z, so that we know now that we are here and we can calculate down and to the right. It should be super easy to implement, actually, if I have that right in mind. So the idea is to change the behavior of the search. And what happens if we get the maze? That can be done small. The neighbors wouldn't change, but would change the following. So is the frontier, so we have to get the heuristic somewhere, and this has to happen before or inside of the stack. And the question is, because we have to remove here, right? And if we are now in a greedy best first search, we would not use stack or queue, or better, we would use any frontier like that. And the important stuff is that we create a remove method which allows us to remove always the one with the highest amount or with the lowest amount of way to the path. So the heuristic would be the Manhattan number. So from here, or Manhattan distance is it? From here to the bottom and from here to the right, and add these values together. And this has to happen in this remove part, I guess. So in order to do that, we have this queue frontier here, which is just an extension of the stack frontier. And what I will do is I will create a class gbfs frontier extends the stack frontier again. And I decide to override also the remove method. Good. So, and in my head, why is this missing return? Okay, will come. So, and here inside we need some stuff. We need access to the start point. We need access to the end point. So I guess we cannot override. It will be an own remove, right? On the other hand, it needs... I think it cannot be the exact same. But we could enter, no. Oh, we can enter that on the beginning. So we could have, give me a second. So when we have this, we could create a constructor with a final value like the start and final end. That I don't have to change the complete different, the complete or search of the other stuff, because the other stuff should be okay, right? It's just where we search the next element that we need. So I could left the implementation exactly the same, and I just would use the same remove. So that is my idea somehow. I don't know if this will work, but we will see. Preferred timing uninitialized. Okay, so the start and end would be a tuple 2. And this is that, we create that, and now we have access here inside on to start. That's good. So now here we can calculate the heuristic, the Manhattan number. And then we return the smallest number. So that would be my idea now at the moment. So we need the start, we need the end. We get anyway the current we have already, or? All right, enjoy your dinner. So we have the calculation of the Manhattan number. How would we get that? So we know the start and end. While the start is not even important, it is important where we are at the moment, or from all the possible ways. From all the possible, well, sorry. We would always take the one, yeah, that's correct, that's all good. So let me think. So we have a current element that we have at the frontier. So as you please. So my idea would be now to say, okay, we have the end point, and we want to remove it with the calculation of the Manhattan number. So calculate Manhattan number. Or just do it. We have the frontier, and there are nodes on it, right? So for each node. And yeah, let's do it with a for each now. Now we have each element is a node. Yes. So we can also make that specific here. Suppress avoid function literals and for each. Not sure what that means. Okay. So, and now I need to calculate the element's heuristic number. So actually what we want is not to for each, we want to just sort it. Sort. And what we get is a node A, node B. Oh, this is compare, node A, node B. And what we want to return is, what does the third returns? It's length compared to B. Compare is omitted. AB. Function must, and this one returns an integer. Okay, and I think that was -1, 0, and 1. And we have to identify now the calculation. So we get the two nodes and we compare them. So a dot state, and here we have the column, right? And we have the row, which is a state item 2. And we have from the end state dot item 1 and item 2. I think end item 1 and dot item 2. So in order to get the difference, so the delta to end, we would say we have column delta to end would be the item state 1 minus the end dot item state 1. And we need that absolute, right? Because that could be in the negative and in the positive. So math dot, oh, my apps just, not sure anymore. So why cannot calculate that? Dynamic can be assigned to type num. A dot state is an int, and you are a t. Ah, I didn't say that this is an int, of course. Okay. We don't need the start. So. Good. And the same thing for the row delta to end, which is then minus end item 2. So this can be gone. And this frontier should now be sorted. What is wrong here? Yeah, okay. No, that was not the trick. Good. Okay, and now we have to calculate both together, like column delta plus the row delta to end. And this is the sum. Heuristic here. No, this is a sum or heuristic. A Manhattan number. So the same thing we have to do for B, right? B column, B delta row to the end. So now I have to make this absolute still. Let me check. Dart apps. On the int class, okay. So int.apps, no. We are in a package int. Okay, we do it on the numbers itself. Fantastic. I knew that it was a bit tricky in Dart, so we have that. And also here. We have to be Manhattan number. So, and these are our comparables. So return a So now the frontier is sorted by the Manhattan number. And next would be that we take always the smallest amount. So now the question is, which one is bigger at the moment? So is the first one larger or the last one larger? We have to see. So return frontier dot first. Now remove at 0. Calc Manhattan number, yeah, so this would be my idea for the whole thing. That means whenever we remove one, we would sort it to get the Manhattan number somewhere. And that should actually be the trick for that already. So when we are going to the search controller, here we would have else if the active algorithm is equal to search algo dot gbfs. Okay, and this would be now not this, would be frontier equals as frontier. And the end comes from provider.endpoint. Good. And else we throw an exception. Valid algorithm. Good. Cancel, something is wrong. GBFS frontier. We have that, we have this. So if we have a wall, No, something's wrong because he should check this one, then this one. Okay, so maybe I'm wrong, so remove last. Maybe this works better. Better, but still not good, I guess. Okay, so we have a start point here, we have an end point here, we delay the whole thing and go to greedy best first search, and then we say he needs to decide between these two. So it should go below and then go up again, and then it should find the way to here and then go down. Let's see, what have we done with our front here? It's just one node. Okay, so of course it has only one option to go to the left. Resume. So next. So exactly left. Okay. Now it has two options, to the bottom and to the top. So, and it wants to go up or down. It should go down actually, which is the last one. Okay, fantastic. So it's correct. It should go down again. Yep. To the right this time. Yep. To the right looks good. Up makes sense. Up makes sense. Right makes sense. So we have from here, we have 1, 2, 3, 1, 2, 3, 4, 5, 6. So that means it would have a 9. And this one would have a 1, 2, 3, and 1, 2, 3, 4, 5. So an 8. So it should go to the bottom. So down would be the answer. It goes to the right. Maybe I miscalculated. Okay, now it has down, down as an action. Why is right missing at this place? It has a lot of, aha, okay. It goes to the right, okay. So the last one is right. The endpoint is 6, 6. And we are at 7, 0. This one. Ah, wait, why make I? Let's see if we go once into this guy here. Nope. Okay. So what do we have? Debugger, and open up that one. So we have 3, 1 here, and we have 4, 1 here. And this GBF has 6, 6 still. So the first one that we get is down, and the second one is also down. But this is completely somewhere else. So it could be here, or no, 3, 1 and 4, 1. So that is this one and this one is getting compared. 0, 1, 2, 3. Yeah, so this one and this one. and they getting compared. So we calculate first the value here. This is -3, -3, -5, and -5. Of course, if we calculate everything negative, then that will not work. That's true. But wait, I want to get the difference. So everything needs to be positive, right? So the end needs to be at least at 0, 0. So both of them are -5. -7. That means 5, 1. This one would be even worse. -6, -6. So 5, 1 and 6, 1. Something is odd. Okay, both rows are on the same line, that's true. So, but here we have a difference, right? So we have 5 and 5. Ah, this is the mistake. Okay, fantastic. If I compare both, always the same with each other, they are always the same. That's absolutely fair. Cannot argue with that. That's the best mistakes. Good, so let's have a start point and end point. Let's create some walls. And let's see with the delayed greedy best first search. Go. Yeah, just go. -10, -10. I think we don't need that one actually. Finally there's a difference, so good. And now he needs to go here, I guess. Should go to the right, should go to the right. Should go to the right. Now it should go to the bottom. Still not. Why is -8 and -10? So which one is at the moment on the top tier? So if I get that out and start that, we get in the front here, the last one is down. At the end it's down. Okay, at least something. So here, 6, 1 down. Okay. This is all wrong, right? So now it has only two options, this one and this one. It should take this one. Yep. So now it has again 3 to the right is 4 and 3. But from here, this point does not have the same value. This is just not right. So let's finish that off. Run. Bop, 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 bop. Okay. This is not only my thinking, this is how it works, right? So if you search for greedy best first search, you only use the heuristic. So that is the idea. Is better than its parent, the successor is set to the front of the queue. Else the successor is inserted into the queue. So greedy BFS, yeah. So you only have the heuristic. You don't have any payment. So this comes with A star, I guess. In A star, you have then the GN, which are the costs, and the HN, which is the heuristic again. And out of that, you will get then the information on how expensive it will be to go from one path to another. At least is my understanding from the course from edX. Wait, I just want to make sure that I'm correct on that, because you never know. Lecture source slides. Boop, 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 lot of text. Transition model, go there, blah, blah, blah. Greedy. Best first search. Search algorithm using the heuristic. Blah, 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 a lot of texts. So, exactly. So this is what we have implemented yet, right? So everything, all the elements has its heuristic. But if we search for the A star search, which comes way later, bop, 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 here you can see here we have now path costs. So this costs 1, this costs 2, 3, and so on. Good. But still, this is not the problem at the moment. Still, I think we have a calculation problem here, and I want to know where exactly. You can just go to the, I think I don't know if I'm allowed to just share it, but if you go to the edX, you can just sign into the course, and then you get all the course materials for free. So voila. So Manhattan, I think should write correctly. Okay, let's try it again. So start the search. Up. So this is the first one, second, third, fourth, stop. So this is the one. Here I want to know the heuristics, and I think I did now again a terrible mistake, but we have right and down has lost against right. Not happy with that. Maybe we want first to calculate that stuff here. And out of that, we want to create then the absolute. So, cancel the search. Steps taken to find the path is also amazing now. What was that? Oh no, I deleted it again. And here? Not quite. So let's see if I remove PDF. So, and we want to have actually here a breakpoint. So go. Good. So now it went to the right, which was perfect. It goes another time to the right, which was perfect. One last time, it goes to the right, which was perfect. So, and now the next time is also perfect. So, and this one is interesting. So we have 16 elements in our front here. And the last two should be, so 1, 2, 3, 4, 5. we should closely come to it. So we have -5 and -5 in the A column delta. We have here 0 and here we have -5. So the end item, no, this is 4. So where is it? This is 0, 1, 2, 3, 4, 5. 0, 1, 2, 3, 4, 5, 6. 6, 6, yeah. Forgot. So 1, 7. So where is the tuple 6, 6? So some 5, 5. Up is 4, 5. That would mean 0, 1, 2, 3, 4. Yeah, it's not that. It's still not that. Nope. Yeah, so here it comes. So we have now the tuple that can go up, and it should be better than the other. So the B has a heuristic change of null, which is amazing, right? Maybe our compare to is wrong. Maybe our compare to is wrong, because 1 is of course bigger than B, but actually we want to get as close to 0 as possible, right? So 3, 7 has also 0. How could that be? It has -2 and the row delta has 2. Okay, I get it. So let's try to make that apps. Okay, so we have our start position here. We create a lot of walls down here. Good. And then we have the ending position here. Let's delayed search. So this is already wrong. It goes in the wrong direction, lost. You just go to the course and then you find it underneath of slides here. So if you are in the course materials, I think there is everything inside. Perfect, Minu, perfect. That is already wrong, I guess. So we have the delta, I calculate. Why is my debugger not working? All right, Minu, I have to open up the window shortly. 25 degrees or 24.6, so it's quite hot. It is in the middle of the winter. Technical stuff really hots that stuff up here. So we have a start and an end, and we have some walls. Did I forget to select the right search? No, that could be. So now I guess I did it exactly the opposite way around. So let's see. No, it's perfect. Ha! Nice. This is correct because this was on a wall, so it was not an option, but he didn't want to go down, so it was able, or it was a solution to go to the left. So with that we have it. Finally. Okay. So it tries to get always the smallest amount of number till it gets to the point. And now we can create our walls wherever we want to. Like this, could create some kind of this. Oh, that is a bit too much, but kind of this. And now I guess we even can create that negative example where greedy best first search getting to a problem, because it will go now up here and then down here and then back inside because we don't have path costing. Oh, that was a bit weird. Yeah, is that how it should work? The same pattern as in the slide? Yep, will do. So let's go. A star greedy best. Okay, so everything that is gray is for them a wall, right? So that was 1, 2, 3, 4, 5, 6, 7. So a columns of no, that's not true. Rows of 7 and an amount of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 columns. Okay. So let's go. We have our starting location down here and our end solution up here. We click the walls. Pop, 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 like this. Then we have here walls. We have here walls. Bringing here one in. I think this was one too much. 1, 2, 3. 1, 2, 3. And to the end. And up here we have it exactly here. No! Alright. So here we have the solution, right? So that should be the trick. Let's see how it works. Okay, still good. Oh yeah. So and the thing is, this one is 7, right? So it could be, so this 7 and this 7 has the same value, so it doesn't it is not necessarily that one of them is checked. So it can be checked, but it doesn't have to be checked. So I guess that's all right. It's not really missed. As I said, it's because of the value. You see, this 7, and this 7 is all the same, and this 7. And it's never going higher than 7. So it only checks the lower ones, and this one, well, I could check that, but it is not mandatory, you know? Ha! That's cool. I'm pretty happy with our solution at the moment. That's amazing. So the steps also working. So we see that it will take 26 steps. If we take the delayed away, it takes 400 microseconds or microseconds. If we make breath first search, it will take 699. Deep first search, 465. And so I guess this is the fast one. Not too bad. All right. So, and last but not least, we have the A star search. And here now we come finally to the cost to reach the node. So this is finally the thing that you search for, Minu. So the heuristic we have already calculated, right? And now what comes into play is the GN. So actually what we could do is, first of all, we push this solution here. So with that we solved the search, solved search, greedy best search. Yep, push the whole thing and ready. And with that we can go to this guy. Why DFS has no yellow boxes? A good question. Let's see. Actually that looks wrong in my opinion, because or wait, DFS, it goes always to the end, so it should look there and it should look there. That looks really odd. So this one is correct, but DFS, I don't know, to be honest. No, it should go always to the end of a node, right? So it should go there, it should go there, and so on and so forth. I think the DFS is wrongly implemented somehow at the moment. Oof. Okay. So DFS is stack frontier, so we should come here, and if this is stack frontier, we remove by frontier remove last. It looks quite correct. The GBFS. GBS? What? Ah, here on that part. Yep, you're right. But in the meantime, that's weird. So inside of the home view, when we change, no, let's make a breakpoint. I think that's the easiest solution. Breakpoint, we are here already. So let's select this one, start search. So the current selected algo is DFS, so it will be a stack frontier. Frontier 0. I mean, actually, I'm pretty happy that it finds directly the right solution, but I'm not sure if this is correct. So where is our lecture? So here. So let's search for the, what was it? Deep breath first, deep first search. So what I thought is looking at the pattern, path, blah, blah, blah. Stack, yeah. So we go into the frontier, take the frontier A, go to B, C and D, we go to D, which is always the last element. So did it sort somehow? And if it sorts, by what? Huh, interesting, interesting. Stack frontier. So whenever we remove one, update cell, add, this is when we find something. If neighbors contains entry values, child node is a new node, we add one. And where do we remove them? Here. Remove last. How do we add them? Just add a node. Looks quite correct to me. So first node, let's make here the breakpoint, then we can see the nodes directly. So the first one is 0, 6. And how does the frontier look like? It has a size of 0. Let's go. So we go to the right, makes sense. Frontier has elements 0, 0, 0, one more. So finally, now we get the right one. So we get 4, 4. 0, 1, 2, 3, 4. But if we are here, we add both nodes, right? So we have also the frontier of 2, 4. Yeah, okay. Could be, but I think it is not mandatory that it always checks the right one first, or? On the other hand, if it is the last one that is getting added, I mean, we cannot identify that, right? We could check that, but it makes no sense, right? We don't care. But does that mean always the right one will come first? That would mean that at this point, latest, we would have to change somehow. So action left. We get to the right. We go now to up. I mean, don't get me wrong, I like that it works right out of the box, but it feels a little bit awkward. So the frontier has now left and up. Can we check before we remove it? I would like to see how it looks in the list there. So the next one has now 1, 2, 3 nodes. So we have 7, 2, which goes to the right. And this is on the last part. It's getting... of course. Okay, yeah, that could be. It's just pure luck, actually. It's just pure luck. I think if we would turn this whole whole part around, so make it the opposite side, it would look completely different. I guess, at least. So if we have a start point here and we would create the question is, why is it changing all to the direction? I don't know if this is correct. Not sure. This will never find a path. Yeah, that's true. It will take time, but okay. Not sure. I would now go to that this is an unlucky mistake, but or an unlucky state, but it works, so I will keep it for now. To be honest, I don't have a good answer. Yeah, but we have that, good. So I think we can close for now this greedy best first search. Yep. Put that here, solved in. Good. And DFS, the depth matters. Yeah, that's true. But that is exactly what I say. I would say that it was just pure luck, right? So with our maze. I don't know if we have another one where we, I don't know, start, for example, on the right side and go to the left. The question is, could it be I I just don't know. I don't know, like so, and we create all that. No, it should go up. Or should it? The problem is I cannot, when I add the next frontier, I just add it at the end. So we have this frontier and we add the child node. And this is just the next one, which could be there. So we have an entry value, contains state. If it not contains, so if we don't have it explored already, and if the frontier does not include it, it trained itself. Now we get the entries from the neighbors. And the neighbors is this part here. And what we do is we add all these into the frontier. So it is pure luck that it... I mean that... this is breadth first search, that makes no sense. Okay, sometimes it does it. Yeah, so now he searches through the whole part and then he goes up. I have an idea. What would happen if I do the following? If I say this comes up here. Okay, so it depends on how I implemented this map. Because it decides which direction will be taken first into account. So if I place both in the middle without walls, so like this and this. Is that what you expected, or? Good, then we are happy, right? Good, so BFS, so greedy best search, we have to still change a little bit. Home view, we have the greedy best first search. Oh, it's getting long. And what we also could do is bringing this selected algo, the delayed checkbox tile sized box, this thing, I want to bring in this row down here, like so. Up. At the moment there is enough space for our debug thingy. Okay, so then a star search, right? The only thing that we don't have implemented yet. Yeah, it crashes, of course, because this is no valid algorithm. Okay. Page 125. Okay, you mean, I guess, the lecture? 125. Okay, but this looks... okay, let's try it. Yep. Start location is on the bottom left, end location is on the top right. We have these walls that we create here and here. We create these two, and we create this. 1, 2, 3, top. 1, 2, 3 to the end. No, that was wrong. Oops. I don't understand my own icons. Good. And then we have this and this. Looks okay, I guess. As I said, this is just pure luck, I guess, because this is highly dependable on... Yeah, as I said, I guess this is pure luck. I think in the... when they talk, you understand, whenever they have this possibility to go right or left, they always decide by pure luck. They just say, okay, I go in that direction that I need. And the pure luck comes from us, from this list of the search controller. So in this guy. So if I turn up and down and change here the way where they are, then I change the whole behavior of that thing. So, but this doesn't reduce the rightness or the correctness of this deep first search here, I guess. Okay, so, but good enough. Next step would be to create the A star search, right? So A star search. Let's see, what do we have here? I think if we search for it, A star, we find this guy. So the cost to reach a node, and this will increase by each step that we do, right? So that means first step has... yeah, 1, 2, 3, 4, 5, 6, 6, 7, 7, and so on. If I have that right in mind, right? So 6, 7, 9, 10, 11, 12. No, pure plus heuristic, but 6, 6, yeah. And next step is 7, 7. Where it is? Yeah. Good. So we have already... Don't try. Come, I let it run for you, just for you. Come. We can cancel that and. Okay. But I'm pretty proud. It looks amazing. I mean, at the end we have like a computer game played that plays for us the maze. Okay, next step, the A star search. So what we will have to do is creating again, I guess, some kind of logic that will take care of that. So if we go to the search controller. Oh, I have to close the window again. So do you have an idea, Minno, where we should start to implement the A star search? Remove, get maze info. We have the view, we have the tuples, we have the neighbors, and we want to have that inside of the... here. So at this place we will have another if and a last else. And here will be the active algorithm equals to the search algo dot a. And then we do our frontier with the a star frontier. And we have to pass in the provider.endpoint at the moment. But I think, yeah, I think it will be the same, I guess. We have to see. So if we look at the utils, we have the Q frontier, we have the GBS frontier, and now we have the A star frontier, which also extends from the stack frontier. And so now we have to calculate the heuristic for each node, actually. So I mean, I'm pretty happy with all that we have calculated here. The only thing is that I don't like is that we have that now in this remove function. It is a bit confusing. What I would like to do is give this node a heuristic, like final with the value, right? It's just an integer, so with the heuristic or Manhattan number. And also final int with its value of the cost to go there, I guess. Cost. So we have to add these fields. And both of them are, of course, optional. Like so. And then we can calculate for each node automatically the values that we need. I think that is a little bit better. And then we can even reuse the old frontier. We don't need to create own frontiers for that. Let's see if this makes sense. That was a bit too fast, like that. And now let's see what we have here. So we wouldn't create this A star frontier. And in order to do that, we need this number and this number. Or better, actually, we need this number here. So what I will do is I create an own method here inside, which I call, can we create own methods? Yeah, why not? We return the int calculate Manhattan number. Up. This happens. I help you as fast as I can. So I watched the course 3 times, so I think I will be able to. So let's see. You don't understand 248. This one or this one? This one. Okay, so the idea is that the combined value is always the lowest, right? So if we see that here it's 17, 17, 17, 17, 17. So in the first time now it differs, right? Because this is 17, but this is more than 17 because the heuristic is higher. So we go to this place. Now if we go further, we are here at 19, right? And 19 is now again equal to this 19. And now both of them are equal again. So this is the only identification. So it goes that path as long as it can until it identifies something that is equally high, and the next step would be even higher because the next step would be a 20, 14 plus 6, right? So it would be a 20, so the next one will be also checked, and then it will go on the other side because it's cheaper. And then it's finishing off the whole path. I hope that was clear. So calculate that, we get a point and the end point. And the point is here. and the other point is here, and endpoint is this one and this one. Tuple 2 of int int, and another tuple 2 of int int. Good. This has no state in that case, and this one neither. If the next path is higher than the current, then it will stop there and try the other path. Correct. Suppress missing return. Okay, so what we will do is return this. And somehow I don't like Manhattan, I guess. Good, so we have that number. And what we could do is now passing in, instead of this, we would do a, comma, and a.state and the end. And the same thing for, get this here, remove that. And the same thing for here. Good, then we compare them. And another thing that we could do is sort a frontier by. So if we create a method here that would sort the frontier, would be a bit mutable. Don't really happy with that, but we could say something like void sort frontier. I will do something, and here we could then pass inside the whole thing, so we get a frontier, kind of a stack frontier, so everything fits. And actually the stack frontier dot a list of nodes we receive. This is our frontier dot sort. And the first compare method that we had was a node A and node B. And this sorts now by the Manhattan number. So actually this guy. And a end. So get the end. This is that, and we don't have to sort anymore. We just call this sort frontier part with the frontier. With int. Good. Okay, and then we compare them. So this is the sort frontier. This is by the Manhattan number. Okay. So still this doesn't work. Yeah, that's true. So the idea behind is now that we make that a little bit easier, that we can say, okay, we have our A star frontier, stack frontier. I will do it now the same way. It's just because I don't know. Let's finish it off first like that, and then we can make it complicated and try to extract all the things and make it beautiful. So we have again a tuple with two int, right? Int. And after that, we have our A star frontier. We can create that. And now we get the override of remove. And here if we sort like that, we would only sort the heuristic, right? So what we need to do is we have to sort a little bit more, because we have always the heuristic plus the costs for that. But this leads to a problem. Where do we get the costs to it there? I think, I have an idea. That could be the already gone ways. We know how many tiles we have explored already. But I guess this is not how it works. We need to give every node after each step at least one higher price. So that would happen where we create the nodes. And this happens down here. No, it's too far, I guess. No. So if node status endpoint, no, here. So here we create a new node and we have to pass down how much this one is valid. So for each time we come into that place, this would be the explored number, right? This determines how expensive this node is. The explored tiles plus 1. So now we have the costs for each node. And can we also calculate easily the Manhattan number from here? So if we have calculate Manhattan number, we have the point, which is the entry.value, I guess. And the endpoint is, yeah, the endpoint. I think we get that from the home provider at the moment, right? Endpoint, no. So yeah, provider.endpoint. Okay, so we have the costs and the Manhattan number now inside of each child node. That would now lead to this removal that I thought. So we don't need this sort frontier, I think. At least not in this case. Let me think. So we have that A star. We get this Manhattan number. So now we say we remove the 1 where A star, we remove the 1 where we sorted specifically. So we have the frontier, sort on node A, node B. And the idea is now that I say a.compare, no, dot Manhattan number plus a dot cost. This is our number, and now we have to compare that to B, right? So this is A overall, don't know, A price or something, and then we have B price. And then we have to compare both of them, B and B. And then we say A overall dot compare to B overall. I'll return that. Good. And then we remove the last one. Oh, this is the wrong way around. So B overall compared to A overall. That's it, I guess. And for this, we can even make it easier now. This method can be inlined because it's only once used. So here we have the A star, here we have that. And in that place, we only have to use the A Manhattan number, which exists already. So we have A dot Manhattan number. And here we have the B. Whoa. Here we have B Manhattan number. And oh, I think I turned around the logic, right? Yeah. So A and B. Can remove that and easy. Okay. That should still work the same, right? So we have now the okay, that's already good. Excellent. Yep. Beautiful. So for the next, we have to recreate. For now, it works pretty well. I don't have any drops in the bitrate actually. Oh, on the other hand, there are some frames overjumped. I don't know why. Oh well, it will do the last hour, I guess, or the last 15 minutes or something. So until we have solved the mystery of the A star. So let's see if... Oh, really? Sorry to hear that. Yeah. Maybe Twitch is not the best option. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. On the other side, YouTube also had these buffering issues in the last couple of days. 1, 2, 3, 4, 5, 6, 7. Okay, that's good. So we have A, we have the endpoint B, and we have walls. Okay, somewhere is a mistake. Okay, so what happened here now? Very close. I was so surprised. I was like, okay, it's working, it's working. Cost calculation. I mean, for one of the next live streams, the next step that we need to do is to display the numbers inside of the part so that we can read where the different heuristics are or where the different values are. Why is it going further? So let's see. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 plus 6. Yeah, because the heuristic is going higher again. This is 21 and 13 plus 8 is... Okay, it should stop there actually. Is 7 is 21. Okay, so probably... What did we do? We calculated the final data. No, where is the A star? Here. So we get the A overall and the B overall, and this is close to perfect. So where is the problem? So the remove last frontier. Okay, it's just having 1. 16 and 2. This here is +2. I think there is the problem. I think this cost is too high. This should be 1. Okay, so this is 2. And now this one is 3. Yeah, alright, so this is the problem. Alright, got it. So this one is 4, but it should be 3, right? So let's see. Yeah, okay. Easy, easy. Found the solution, no problem. Don't make +1 here. So, restart. Try it again. You too. It would be great if something works right out of the box, right? If you don't have to care about and everything works right away and easy peasy. So, all right. So we have our 12 again. We have our 7 again, I guess. And now recreate that maze. True, true. Put that on top, put that here, give that to the side. Get that down, create that to the side. Oh, I think that was too far. Nope, and close that off. Create a path and delete, of course. And broken. Okay, out of some reasons it's jumping over there. So 1 plus 16. Okay. Let's see where we're coming to. So we get this B overall, right? So what is the first heuristic? I mean, that should be pretty easy, right? Null, exactly. So, and then here we have the 16 plus 1. But now let's be honest, this looks exactly the same. So now we have 15 plus 2, which is also correct. 14 plus 3, yo. 13 plus 4, 12 plus 5, 13 plus 6. So let's see, we go not here, but here. Oh, 5 plus 12. The Manhattan number is wrong. Ha! Why is my Manhattan number? What is wrong here? Go away. So my Manhattan number is wrong. It's 13 for me, but it should be 12, I guess. And the 13 is on the left side. Oh wait, maybe it's right. So this one has 13. No, it's correct. And 11 for the other. And 11 for the other. Yes. Okay, so that is correct, actually. I did not say anything. 10 and 7, 9 and 8. Getting lower, getting lower. So it has still the possibility to go to the left to this position with 19. And it has the position to go to this to also 19. So it decides for the first one, all right. So now here it has the possibility to go to the left and down, and both have 21. Is that correct? No. So you see 13 and 6 is 19 and this is 21. So this works. Now here comes the game. So if we want to go down, we have 6 plus 15. And here on that side we have 16 plus 14. Ah, alright, that's not good. Of course, I get it. The problem is the costs are the costs from the previous plus 1. So that means we say now that this one, because we use the steps that we have taken already, so we just add that into it, and this is wrong. So that means this is 14. Yeah, this is completely off. We should have here 6, 4, 7, 8, and so on and so forth. So what we have to do is wrong implemented at this point here. Where are we? So the costs. I said that these are the explored tiles, which is not quite correct because it is the node.cost plus 1. Exactly. So the first node will have to have a cost, and if it is 0, but it needs to have 1. So where is my first node? Start node. Here's my start node. This guy. It starts with 0, I guess. Yeah. Okay, so this will work, I guess. Okay, maybe I have to create some templates that I don't have to recreate these mazes all the time. Start and end point. 1, 2, 3, 4, 5. 1, 2, 3. Getting that to the side. You go away and you go away. So let's see, what does our frontier says. So we have our first, which has a cost from 0, a cost from 1, cost from 2, cost from 3. Why do we don't make that beautiful? Why is it not coloring anymore? Ah, because I didn't delay it. Aha. Okay, that looks good and way better than before. So let's make it with delay again. Here we go. Very good. And we are done. Nice. So if we used greedy best first search, I think it will go to the top, right? Yep. On the DFS, I could imagine that it could go still wrong, and BFS will anyway take everything that it get. Boom! Fantastic, now I have something to Twitter about. So I think the application in general is first of all ready to at least, yeah, show. Amazing, I'm really happy with that, that's so cool. I guess so, yeah, because it goes to the left and then just sticks with it and brings it to the end. Cool. And yeah, DFS is the only one who could maybe break the game, but I think it's correct. Okay, so all the search patterns are implemented. So, and whenever I do the next live stream, hopefully tomorrow, then I want to clean a little bit up again, to maybe clean up this stuff. On the other hand, it works. Why should we? And then let's see what we can do next with that, or if we even go further with our training. Because if we take a look into the course material, if I have seen that right, because everything is anyway with no legal boundaries, as you can see, there are no rights reserved, besides of that I'm not allowed to earn money with it and share alike and so on and so forth, so there shouldn't be a problem, and I think I give enough attribution to it, so maybe we can also watch the videos together and so on. That would be amazing. So the next step would be knowledge. Let's see shortly the slides. Based agents, if I didn't rain. So yeah, and I think this is just 99 slides, so it should be fairly simple to understand, right? If we take a look here, a lot of just some minor mathematics. Does A and B, no, sorry, or B, does A or B, and I don't know what this sign is, to be honest. Entail A and B. Okay, from the short overview, it's looking freaking amazing. Hey, each other, nice to see you. Adversarial search? Adversarial search. What is the adversarial word? Is search when there is an enemy or opponent changing the state of the problem each time. Chess, business, trading, war. Ah, you mean, yeah. We could also do a min-max solution, but I think for that we would need a whole new application, right? Where we play tic-tac-toe or something. And thank you for the raid, by the way. Never had something like that. So, okay. Down here we have the min-max solution. Ah, and this is where you come with the adversarial search. That's true, and then that's why I want to go further with the training, because in the next training we have the project. I took already a look into it, and there are two new projects. One is Knights and the other one is Minesweeper. Oh, that's no problem. I'm very happy with one viewer. It's one viewer more than before. And actually, I care about every viewer. As long as someone watches, I'm really happy with everything. So, okay. Yeah, and well, this is now the end of the stream, actually. So, thank you very much for joining, Minu. It was fantastic to work with you. Thank you. It's Ash Alve at the end to just join in. Sorry for you that I couldn't show you more, but maybe I can give you a quick demonstration, and I will do that with the Twitter together. So then I can prepare everything together here. So let's open up Cap. Nice little animation tool that I can create stuff with. Ah, fantastic. So then let's see. Let's start the search. Nice, good to know. So that is DFS, which works. And then we have BFS. Yeah, I'm really happy with the solution now. We have now made all the search things from the AI and put them together, so that we can now watch the different solutions, how they work, where they search first, and where the solution comes from, and which is the best solution dependent on the different search types that you use. So here, greedy best first search goes, of course, the shortest way to the heuristic, which is always there. My bitrate is okay. I'm sorry, Minu, that can't do anything, promise you. And the last thing is the A* search, where we go into the different levels. And now you see it breaks there because it's too slow, so it's going the other way around to find the optimal way. And that's it. Cool. So we save that as our example or solution for today. Discard. Oop. What happens now? Okay, and cancel. So nothing will change. Okay, guys, thank you so much for joining. It was a fantastic stream today. Really appreciate everything. And if you are interested in more of AI or so on, please join me in the next time when we will take a look at in the adversarial search, or we will check out the other part. Oh, you have a question? Sure. I can wait. Let me check. My stream quality at the moment is set up at. So my video output is on 1920 to 1080, and the stream bitrate is 4200. And how much does it look? Yeah, 1080 60p. And yeah, important is also that I put the frame rate to 60. On the other side, I think in the future I will reduce that a little bit because yeah, I think 60 FPS is not necessary for the live coding stream. On the other hand, it's better to look at. So yeah, as I said, if you would join me for the next stream, we will most likely talk about adversarial search, or what we will do is we will go further with our edX knowledge part here. So there is the lecture of knowledge, and as you know, the CS50 is completely for free inside of the edX tutorial, so check that out. And if you have any question, feel free to reach out on Twitter or be there tomorrow when we work further on this stuff. Additionally, if you find any problems, because we have that GitHub repository here, if you work on that and you find any issues, please let me know, create issues, work with me together, that would be fantastic. I will quickly share some links, then you have them too, and silence here, bring that in. And the other one would be edX and the AI course, so Introduction AI. Where is it? Here we go. All right, so see ya everyone. Enjoy the rest of your day and see ya tomorrow. Bye.